Hello friends, my name is Rishabh Raj and I'm a first year student at Bits Pilani. And today with me is Kanishk Bhaiya, who is a fourth year student right now at Bits Pilani and is from mechanical branch. And yeah, hello.
Hi, thanks for having me here.
Friends, this is a series in which I give an overview of the courses that are generally taught in like engineering branches. Today we would be talking about mechanical branch and Kanishk Bhaiya would tell you about mechanical branch in a basic way so that if someone who will come to BITS this year can make an informed choice or a person who is in first year can know better about his or her courses. And the first question being
Yeah,
that could you please tell about the overview of the courses? Like you can just give a summary of the courses that are taught in second or third year. Because in first year, generally all the courses are taught to us in BITS Pilani. But from second and third year, you are taught whatever your branch specific courses.
yeah. Like you've asked second and third year, I'll first give a small overview of the first year as well, because there are few courses which are related to mechanical engineering, and yeah, two of those courses like they are thermodynamics and workshop practice. So these are actually prerequisites for most of the courses in the second and third year. So like I'll give an overview of these two courses as well. So thermodynamics is kind of similar to what you've studied in class 11th and 12th, but like one step higher. You have like the all the laws, first, second law of thermodynamics. You learn about not just the heat transfer equations or the conservation of heat equations, but also the entropy and extropy and all those concepts. And one important concept which you learn in there is how to read steam tables, because they include all the properties of not just air but some other fluids as well. So that course will serve as the basics of like three or four courses in your second year. The second course in your first year would be workshop practice. So this is you just go into the workshop, you perform different experiments like how to machine and lathe. Um, there's welding, casting, carpentry, and all that. So yeah, like for me, it's pretty fun course. For others, it could be like kind of labor oriented, but yeah, that's like how you look at it. There's also course engineering graphics. That's kind of like common concept between both mechanical engineers as well as civil engineers. So that gives an overview of how you'll be like drawing stuff in two dimensions. And from that course, like you learn how to design stuff in 3D, and that's something which comes in second year. So moving on to second year, there are four courses which you'll do specific to mech. First course is mechanics of solids. So what this basically teaches you is everything related to the stress strain curve. That's something which you learned in class 11th and 12th. And also like torsion, deflection due to bending, anything related to mechanics of solids. Uh, a lot of those concepts would involve things which you study doing a JEE Advanced preparation. Not means advanced because it's a little bit higher. So like if you're able to like revise that properly, then it should be simple for you. Then the course after that is material science. You might have not, I don't remember if we did this in class 11th or 12th, but it mostly like relates to alloys and how you can change different properties of materials with, let's say, different specifications of uh, compositions of the alloys, or even at different temperatures and cooling processes. So that course serves as the basics of material science, in the sense that if you aim to like pursue materials in specific like through masters or PhD, then you really need to like get the hang of that course. Then the third one is applied thermodynamics. That's just the thermodynamics you studied in first year, but one step higher. So you get to know about the different mechanical devices existing in the industry. Could be like turbine cycles, compressors, boilers, even air conditioners. So that's how you apply thermodynamics into the real world. And there's also fluid mechanics. Yeah, fluid mechanics is mostly mathematical concepts only. So you learn about control mass, control volume of fluids, and that also serves the basics into like, let's say, computational fluid dynamics, which like many people take up as a career option later on. Then the second semester you've got advanced mechanics of solids. So in mechanics of solids in the previous semester you mostly learned about two-dimensional stuff, but in advanced mech-sol you learn how to let's say model the solid mechanics in three dimensions. Then you've got manufacturing process. Now this course kind of gives you the starting of manufacturing, which is a separate branch in bits, but being like mechanical and manufacturing being like having, they are like sister branches. So you'll have to like learn some concepts related to manufacturing as well. So that course, manufacturing process, gives you like an overview of the olden or much more established process like casting, forming, and welding. And there's another course in third year, which is Advanced Manufacturing Process. That gives you an overview of the current technologies in manufacturing. So you've got different machines like EDM, CNC, computerized numeric control, and laser machining, and all those like intricate, unconventional machining process, which those devices are expensive as compared to like the traditional process, but they give you like higher control and higher accuracy. There's also heat transfer. Again, heat and fluid transfer, they are kind of similar in terms of the maths you perform. Like there's lots and lots of differential equations involved. But yeah, like people kind of combine heat transfer and fluid transfer, and they research on it further. And yeah, one benefit about heat transfer is you get to study with one of the best profs on campus. So that's something like which, like I think all of us have enjoyed the heat transfer course. Then there's mechanisms and machines, which serves as the introduction towards the robotics side of mechanical. It kind of gives you an overview of how, let's say, mechanisms they move with respect to each other. You get an introduction to devices like gyroscopes and flywheels, how to balance different reciprocating engines, and yeah, it also introduces you to modeling and simulation tools. I think we had kind of studied like the introduction of MATLAB, and developing skills like through these courses, it gives an advantage on your resume. In third year, the main courses are the design of machine elements. So in Mexol and advanced Mexol, you kind of like learn about the stresses or the force analysis in solids. Now, based on those understandings, you now understand the methodology of designing a specific product. Based on like different constraints, like it should not fail or it should not bend or deform. So it also introduces you to 3D modeling, which is like one step ahead of engineering graphics, in which you mostly use Fusion 360 to model devices in 3 dimension on the computer. So that's also something like in which people really have lots of fun. You also get introduced to management type courses. So that's something like which you start in your second year through like principles of management form or POI, principles of economics. Apart from that, there's manufacturing management, which you have to study in MEC. So that introduces you to, let's say, how to forecast your manufacturing process. Where should the facility be located? How should the layout be planned? How should you plan your production, your batches, scheduling all these activities? And you also get introduced to like concepts like just-in-time or lean manufacturing, and also supply chain management. And like if people are interested in that line of mechanical, they can also take electives, and there's a lot of job opportunities related to lean and supply chain management. There's also a course on engines and motors, so that mostly gives you an idea of how combustion engine works, mostly petrol and diesel, two-stroke and four-stroke engines. I think like in the latest curriculum, they've also introduced to you some modern solutions like electric vehicles. So that's something like which also you'll also get to know through this course. In the last semester, you learn about vibrations, which is yes another important part of mechanical engineering. And vibrations is mostly like how do you control vibrations in different machines. And this mostly involves like coding on MATLAB. So again, you kind of uh, get an overview of how to program stuff on MATLAB. And you also are introduced to control systems. And control system is kind of a link between mechanical and electrical engineering. And yeah, control systems also used in stuff like robotics, mechatronics. And there's another elective on that. So if people who are interested in this course, they can later on take an elective in control systems. There's also computer aided design, and that is a course which is it's kind of different from traditional mechanical engineering. So in the sense that it gives you an overview of Python and how to like perform geometric transformations or mathematical modeling on Python. It also gives you an overview of finite element method, which is an important numerical concept in mechanical and civil engineering. And yeah, there's machine drawing as well. Some more in-depth details about CAD, which you had learned in design of machine elements course in the previous semester. Yeah, I think that's mostly an overview of, yeah, there's one more course, engineering optimization. That's something like, it's not specific to mech. Every single branch has that engineering opti course. And it teaches you like different optimization methods and how you can perform optimization on certain softwares like Dora or Excel. So that's not specific to Mech, that's mostly specific to all the engineering branches. I'll also give a brief overview of electives. So let's say like towards the starting of your third year, you get an overview of different concepts within mechanical. You can take electives in the management side, which is supply chain or lean management. You could get into robotics. If you want, you could take CS courses as well, and maybe like kind of become an interdisciplinary person in terms of like using artificial intelligence or ML within mechanical engineering. There's also sustainability type of courses. So yeah, lots of options for you depending on how you explore your branch.
Yeah, one more thing I wanted to ask, in our childhood, we always used to listen about automobile engineering. So is it a part of mechanical? Because
Yes, so there is one elective on automobile technology as well. So automobile engineering in itself is like pretty broad. So you not just learn about the design of automobiles, but there's also lots of fluid mechanics involved. And yeah, fluid mechanics is something which you learn in detail in your second year. And there's also a computational fluid dynamics course which you can take as an elective. So that is like one important concept of automobile. There's also engines. So yeah, you get started off with combustion engines, I think in your third year, and that's also something like which involves automobile engineering. And regarding like the opportunities, so you have like Tata Motors, Bajaj Auto coming in for placements. There's also Mercedes-Benz, which comes for PS2, and they take around 20 to 30 students each semester. So regarding automobiles, like the knowledge which you gain in the course is pretty substantial. And if people like want to explore it even more further, they can take a master's in automobile engineering as well. So there are certain masters in Germany which they have the benefit of being like the automobile hub of the world, and the tuition fees also over there is like pretty substantial, like pretty less. So what people do is like if they want to explore automobile in detail, maybe get a master's or even a PhD, they take those automobile courses over there. So yeah, in conclusion, like you get an overview of different concepts, not just automobile, but also like let's say robotics or computational science and all that. And if you want, like you can either go for job opportunities in that specific sector, or you can go for masters in that sector.
so the next question is matlab in context to Bits Pilani, how would you rate the mechanical course in comparison to others? Like, for example, like many people say that electronics is one of the toughest courses and civil may be on the lighter note. So in that way, if you would like to say something about mechanical.
Yeah, it's I think to a certain extent it's tough to compare different branches because one person has not like explored like every single branch, and if like two people from different branches try to compare with each other, like that's another debate in itself. But according to like what I've heard from my batchmates, so like electrical is supposed to be the toughest engineering branch, and that has kind of become a universal truth. And civil, yeah, civil also I've heard it is the lightest course among all of them. I think mechanical would stand somewhere in between, somewhere on the average side in terms of the toughness of the course. So there are like certain courses which are pretty easy, certain courses which can take a lot out of you. Lab courses are also something like in which you have to like study the theoretical parts as well as perform the experiments in the lab. So that's something which is there in every branch. So you can't really say that mechanical engineering is tougher or easier, but I would like rate it somewhere in between electrical and civil. Like if I compare it with chemical as well, so I've heard chemical has a lot of tests, but ultimately like their grading balances out their toughness. So it's kind of tough to say which branch is easier or tougher, but I would kind of rate mechanical in between only. Like not so tough, but at the same time, it requires some effort out of you.
Maybe you can tell in a manner like you can tell how much time do you get after all the courses.
I think you get ample time for doing like everything else. It depends on how you attend classes or how you study. Like people have different studying patterns. So for me, it was pretty easy to manage, let's say, the course with my projects and extracurriculars. I think like for a lot of us mechanical engineers, it's been kind of simple. Yeah, but towards like the end of the exams, it kind of gets tough for some people. And if I compare it with the ease of my batchmates, let's say chemical, yes, it takes a lot out of you. Some people are able to manage it, but chemical has a lot of tests. Like every week, you have like one test every day, something like that. So mechanical is not that hectic. So in mechanical, you'll mostly have like every week 2 or 3 tests on an average. It can get like more hectic towards the end of the semester, but yeah, compared to other branches, it's kind of average.
So the next question would be about the future possibilities, if you could tell, like what are the job opportunities, higher studies, etc.
So yeah, one disclaimer before this, like whatever opportunities I say right now, it can be different for let's say 2 or 3 years down the line, especially with like COVID coming in and out. So yeah, like what I've noticed is that the opportunities which I was told by my seniors when I joined the college and the opportunities I'm seeing now are pretty much different. Like some companies have gone out, but new companies have come in. So yeah, it's quite variable, especially in mech because the industry keeps changing pretty much. So you have like Industry 4.0 going on right now. Things are changing from like less traditional concepts to more interdisciplinary concepts. So you have not just mechanical, but you have electrical and CS coming into mechanical industries. So in that case, like the job opportunities vary a lot year on year, but a lot of like common companies, like in terms of automobiles, which I mentioned before, you have Tata, Bajaj, Mercedes coming in for PS as well as for PCs. That's like some place where like a lot of people go to. In terms of like the management side of it, so you have manufacturing management, which I had talked about earlier, and people also take supply chain management course as an elective later on. And with that knowledge, like you could get into supply chain or operation type of roles. Companies like Nestle, Mondelez, HUL, so these are like common companies which come to Bits at least. I think like PNG, I'm not sure if PNG comes or not, but yeah, for operation side, that's like 3 or 4 companies coming in. And there are a lot of off-campus opportunities as well, especially in supply chain, because that is one place which is like people hectic. You need like lots of people in that field. Um, Other opportunities could be in terms of robotics. So there are like a couple of startups which are really working on the robotics aspect, but the skill sets required in that would be kind of different. So you have not just your own mechanical engineering knowledge in terms of like let's say how to design different machines and how the mechanisms kinematics of robotics go on, but you might also like either need to have a data science minor or take courses, electives, like not just electives, but also like you can get in your own skill sets in things like ML, AI, or coding in different languages. And through that, like there are certain opportunities, like a couple of PS stations in robotics come, but apart from that, like off-campus opportunities can also be available. For people like who are kind of confused whether to go for placements or masters, so that is something like in that is a place wherein a lot of like opportunities are there for mechanical engineers because within India, at least, like there is uh, kind of like a stagnant point of job opportunities in core engineering. Um, and like there are a lot of people like who go unplaced as compared to let's say people who are in CS or IT. But that's like only within India. But if you see like abroad, you have Europe, US, even countries like Australia and Japan. So over there, the demand for engineers is like pretty high, and the number of people applying is pretty low. So that's how mechanical engineering can be put into an advantage. Let's say if you go for a master's or even a PhD in these countries, then the job opportunities which you get after that is pretty good. So a lot of people go for that as well.
So what I have understood is that interdisciplinary would make you a better placed person.
Not just a better placed person, but yeah, like placement is one of the most important things which people look into. But apart from that, like you have research as well. A lot of people go into academia or like corporate R&D, let's say after masters or PhD. So even in that case, interdisciplinary is important, especially because the mechanical engineering course which people study now in the 21st century, it has a lot of simulation science or computational science involved. Like I mentioned, a couple of courses, like you get to learn about MATLAB and Python. A couple of mechanical projects which I did and which I will be doing in my final year, they are related to C++ and object-oriented programming. So interdisciplinary is something like which, yeah, like professionals have told me early on when I was in first year, and I feel like that is an important point if you want any opportunities later on, not just placement opportunities, but also internships and projects.
So the last question would be, If you could tell the most interesting thing in your course which made you love mechanical.
Okay, so in my first year, the thing which made me love mechanical was workshop, and people consider that to be like labor-oriented work, but I considered it to be creative work. Like I was in control of whatever device or let's say whatever part I made. There was like not much of theoretical stuff involved. It was like just practicing and developing your hand skill sets. So, like the manufacturing part side of mechanical is something like which I really enjoyed. Even thermodynamics to a certain extent, kind of like piqued my interest. And later on, like as and when the courses were going on, few courses I liked were mechanisms and machines. So I'm kind of like interested in the computational side of mechanical as well. And my final year project is into robotics. So mechanisms and machines was like something which really piqued my interest. And my PS1 project was also based on mechanisms and machines. And that kind of like it gave me a base for whatever projects I did later on. So I had projects in C++, I had projects in robotics and mechanisms and like one or two even in sustainability. So that course, yeah, mechanisms and machines, it started off all my future interests, my future projects. And towards the third year, like I had started learning Python as well. And so computer aided design, which was in my last semester, my 3-2, that's also something like which kind of piqued my interest in applying whatever Python I had learned into like whatever assignments or projects which they had given me. So yeah, these three courses, mechanisms and machines, CAD, and workshop, that is something like which interested me a lot. For different people, it's different things. So a lot of people are interested in heat transfer and heat transfer. What else? Fluid mechanics. So fluid mechanics, heat transfer, applied thermodynamics. Um, so these courses like interest people a lot, and then they go on to like let's say research in these fields. A lot of people go into PhD as well, specific to heat transfer and fluid dynamics. So yeah, it depends from people to people what are the interests, but it is a fun course, I'd say. If you are interested in these concepts within mechanical, some people they say at the start they're interested in coding, so they want to take CS. What I personally feel is that if you know coding, you can get into any branch of engineering because 21st century engineering applies coding a lot. What I intend to say is that people should not restrict their options because they like coding. There's a lot of opportunities and projects which you can do to develop your interest in coding in various engineering fields as well.
Okay, so that was the end of the video. Thank you guys for listening, and I hope this video would have helped you.
We can build a treehouse in the park.